Hey, folks. Welcome to another episode of Inside Hydraulics. I'm your host, Josh Robinson. Uh, I am joined by a fellow Josh on the product team. Josh Chase is here today to talk about hydraulics on AWS. Josh, how are you?
I'm doing great. Thanks. How are you?
I'm doing pretty good,
Got through another successful week at Hydrolix, so feeling good. This is a good way to exit the week. Having a
for
nice conversation.
sure. Um, as we talk about hydraulics on AWS, for those who are like unfamiliar with observability in the cloud space, could you start by explaining like what managed observability means and why it's crucial for companies utilizing AWS's like edge services?
Sure. Yeah, that's a nice easy place to start. Um, so managed observability is, as the name implies, a fully managed service that SaaS software as a service system that provides observability for those AWS Edge services and also for third-party services that those same customers may be also interested in having observability for. So that would be like CloudFront, WAF, the elemental services, and potentially again third-party services like other CDNs if they're multi-CDN or client logs if they're using media viewers that can emit logs and things like that. So it gives them observability into what's happening with those edge services in real
Mm,
time and historical, and it's a fully managed service, meaning they don't have to figure out what AWS services to use, where the data is going to be stored, how it gets transformed upon ingest. They don't have to figure out how to create dashboards. They don't like it is fully baked off the shelf from the time they click free trial or purchase in AWS Marketplace to the time they're looking at a live dashboard is less than 15 minutes. So
wow.
the management is key in that it makes much faster time to value for the customer. They don't have to have weeks or even months planning everything out, figuring out how to architect it, design it, implement it, test it. And they're saved from the long-term operational complexity and cost of it as well, because Hydraulics monitors the solution 24/7. We observe the observability solution for them. So we monitor it, it automatically scales to whatever volumes they need. As those change, we give regular updates to the software, new features, so on and so forth. So it's completely managed. It's literally just point and click from their perspective.
Awesome. So as hydraulics is building out these solutions, like what specific pain points um, were you seeing in the market that led to the development of hydraulics for AWS? Like, and what were companies struggling with before the solution existed?
Yeah. So kind of leading into that was actually the second part of your first question that I didn't answer. Apologize. Was like why is this important for these particular services, these AWS what they call edge services?
Mhm.
And it's particularly important for those customers because if they're using those services, those are the services that their end customers are directly interacting with, right? Like that CloudFront CDN is delivering the bits directly to the end user.
Mm.
The elemental streams are generating those live streams in going into CloudFront, and media tailors inserting those ads that the viewers are getting and so forth. So these are the services that their customers are directly interacting with, which makes it super critical that you know exactly what type of experience your customers are getting. So that's the importance of observability for those AWS Edge service users. And to answer this question of, well, what were they doing before this and what were their challenges? AWS does have bits and all the bits and pieces for these
Uh,
customers to string together their own observability solution. So they absolutely can do that. The problem is the complexity and the time and the cost in doing so, and the not only to set it up and get it working, but then also creating the dashboards and tweaking them and not knowing what you're actually interested in seeing until you see it and things like that. So our dashboards come pre-baked with hundreds of customers' experience of what they like to see in their dashboards and how. So they come pre-built for you. You can tweak them if desired, but you get the benefit of all that hydraulic experience in the dashboards you get. And again, setup cost, setup time, and complexity is basically none, less than 15 minutes. So it saves a lot of cost and time at the front end setting it up, and then of course the ongoing operations and care and feeding of the solution are also off your plate. So again, it was entirely possible to do it all in AWS, or to buy some third-party system and again do the integration yourself. But we've done everything for the customers so that it just automatically works with these AWS services for Hydrolix.
That's awesome, especially when you're offering services that, like you said, it's almost like an out of the box solution, right? Um, in some of our collateral, we mentioned that Hydrolix can perform sub-second needle in a haystack queries, right, across massive data sets.
Yeah.
Would you, would you be able to walk us through how that's technically possible and why that speed matters in real world scenarios?
Yeah. Um, so yeah, it almost seems like when I first got to Hydrolix, I was like, oh, come on, really? Like you've completely disassociated the size of the data set from the performance of the query. I find that hard to believe, but having seen it for myself in real production reality with real customers, including the largest sporting event in North America, like it's true. They've done it, and they've done it through actually a combination of architectural choices and optimizations.
Mhm.
I can't. I'm not the right expert to go through every single one of them, but I can like mention the top three
Yeah.
that are the most obvious differentiators, technically speaking, that make that possible. So the first one would be start at the beginning when we ingest data from a data source like a CDN or a WAF log or something like that. When we ingest it, we, unlike many other observability solutions, we take the extra compute cost hit up front at the time of ingest to fully index every piece, every log field that comes in for every
Mhm.
log event. And by indexing it, what I mean is when we store it in the storage table, we know exactly what row, what column that piece of data is in, and we keep a record of it. So anytime we need to query that data, we don't have to sort of narrow it down to the nearest partition and then open the whole partition and pull a whole block of data from a certain range and then search that block and find that piece of data, which is what many um, data solutions have to do because they're not fully indexed. We know in advance before we even go to the storage tables exactly where that piece of data is and exactly where every piece of data that is needed to fulfill that query sits in a potentially massive storage set. So we have extremely precise queries, targeted
Mhm.
queries to specific pieces of data, and that makes it very fast. No searching, no seeking, no pulling extra data that we don't need and throwing it away. So super efficient, super fast queries because they're fully indexed from the beginning. That's the first piece. The second piece is because we focused solely on time series, uh, time stamped time series data. That is what we do. That is all we do. That gives us certain advantages. So again, you have huge amounts of data broken up into different partitions, and then when you are going to do a query, you now need to figure out which of those partitions you need to actually take the time to open up and get data out of. Um, because we are time series only data, each of those partitions has a starting timestamp and an end timestamp, and all the
Mhm.
data in it is in between those two timestamps. So we don't have to open up each one and look through it. We know exactly based on the time of the query, the time range of the query, we know
Mhm.
exactly a priori which partitions we have to go access and open up. And then again, because it's fully indexed, once they're open, we know exactly which fields to go pull from each of those partitions. So again, two architectural optimizations that we made from the very beginning that make our queries extremely fast, even for really large data sets. The final piece, the third piece I'll mention, is this one is a pretty nifty hack. I had no idea we did this until I'd been here a while and heard somebody explain it. It's not a hack, but it's a pretty clever use of object storage. So We use standard object storage, which is not known for
Mm,
being particularly speedy, right?
mm,
And it's priced accordingly. Um, so that helps keep our costs low. Well, it turns out if you look exactly how S3 storage works and where it stores the data in its internal hierarchy, directory hierarchy,
mm,
that dictates how many tasks can simultaneously write or read from that particular partition. And so when we store the data in S3, we intentionally store it in the directory in such a way that when we want to read it, we get maximum serialization of those tasks, of those read tasks.
mm.
So we've used the actual architecture of S3 itself to maximize the parallelism that we can get, and therefore the bandwidth of reads we can get at once from an S3 bucket. So that's just another little clever tweak that we've done. Of course, there's countless other far more nuanced and technical optimizations that the engineering team has put into our architecture and our software that I'm not really the right person to go into, but those are
Yeah,
the three big ones. And when you add those all up, you get this magical ability to get SSD-like performance out of simple, cost-effective object storage. Yeah, it
awesome.
almost seems magical, but it's
No,
true.
it is. It absolutely is. I think one of the other key differentiators outside of how fast we can find things is the retention.
Mm.
And so why is long-term retention or data retention so important for observability? Like, how does that compare to what you would typically see in other solutions?
Yes. So typically, I mean, the type of customers that we've run into that have switched from other very well-known observability solutions to Hydrolix, um, we're seeing as little like retentions as small as like less than a week, um, and as large as maybe 4 to 6 weeks, maybe 2 months
Hmm.
at the very high end of a customer who's willing to pay a lot of money to keep it for 2 months. And by default, and now this can be changed on a per table basis for any customer that wants it to be changed higher or lower. But our default setting is 15 months, and we still advertise a 75% reduction in overall cost, total cost of ownership. So that's an amazing double whammy. Is not only can we do maybe up to 5x or maybe even 10x our current retention for our
Hmm.
customers, but it's at 75% cost reduction overall compared to the shorter retention period. So it makes a huge difference. And again, the reason we can uh, offer that is because we do use very cost effective S3 object storage, or actually any object storage. It doesn't have to be S3. Um, and we also have an incredibly effective compression algorithm. So we actually look at the type of data that's being brought in, and and then we pick the best compression algorithm for that shape of data. And it could be a different compression algorithm. If you have four different sources of data coming into your Hydrolix instance, we can actually pick a different compression algorithm for each of those four data sources. And so that way we can pick the best one for each one. So at a very conservative, what we use for cost modeling for our customers is a 12x compression rate. But in reality, we see 20, 25, 30, sometimes even up to 50x compression rates in the real world. So um, that makes the retention costs much, much, much lower for our customers. Why is it important? Well, imagine you have a, an annual e-commerce sale, right?
Hmm.
Like Prime Day, or I'm sure all the other big e-commerce folks have a similar sort of annual sale, or leading into the
Hmm.
holiday season with all the game releases and all that stuff. Or you're sporting an esports media entertainment streamer, and you have large live events. In all those cases, you're going to have seasonality to your traffic, and you're going to need to look back on what has happened over the past season and even before the last season to see what led up to the peak of an event you saw last year or last quarter or however often your events are. And you need to be able to learn from those patterns so that you can predict what your capacity needs are going to be for your next event, right? And so without that long retention period, you don't have that ability. So that's one really important use case. If there's any seasonality to your content that you're streaming,
Mm,
you need to be able to look back at what's happened to plan for what's happening next, essentially, and that's super important. The um, the other reason that a lot of people overlook that long retention period makes a non-issue is you don't no company knows in advance exactly what all their observability needs really are, right?
mm,
New things happen. You're like, oh, we should start tracking that. New stakeholders come in. They have new requirements. So it's impossible to predict what all of your observability are going to need in advance of when you actually start collecting your data. If you just collect all your data and keep it for 15 months, then that's a non-issue because any new observability requirements that come in can retroactively look back at the last 15 months and find all the answers for them. So, but if you've summarized or had to completely throw away that data, then you can only add new observability metrics moving forward. You can never look backward. So that's another problem that it makes a non-problem. And then finally, you can't go you can't go through one conversation today without bringing up AI. So we might as well do it. Machine learning and AI, the quality of the results you get out of those tools, which are becoming more and more powerful and becoming downright business critical, the quality you get out of those tools is directly related to the comprehensiveness and volume of data you put into their training, right?
mhm,
So this data needs to be full fidelity and lots of it. And it can be used for machine learning, like capacity planning, which I mentioned before, or detecting patterns of piracy, online streaming piracy, or whatever it is you're trying to train an algorithm to do or your AI system to do. You need all that data. It needs to be full fidelity. If you try to summarize it to save costs, well, that's a human who summarized it, who didn't know what metrics the AI was going to, what patterns the AI was going to find, and probably threw away all the data that the AI could have found patterns in. So yeah, super important to have all that data for those purposes as well.
no, that's super smart. I think, as you mentioned before, in the media and entertainment use cases, even if they're seasonal, what does Hydrolix help media and entertainment companies do in real time?
Mm. So yes, subquery response performance gives you the real-time aspect of the solution. So we've just been focusing on the historical retention value. Real time is, again, really critical for the services that your customers are directly interacting with, whether it's your e-commerce website or your media streams that you're serving them. You can't, the only way to proactively monitor and ensure a quality of experience for those customers
Mhm.
is with real-time observability of those services and detailed, meaning not just a few metrics, all the logs for every request, for every segment sent, whatever the case is. Um, and if you have that real-time observability, when I say real-time, I mean measured in seconds, not minutes. Then you can actually do something about it when something happens. If you see a metric um, going the wrong direction, a spike in errors or an gradually increasing time to first byte or something like that. You can alert on those types of things when they cross a certain threshold, and then in real time you can know there's a problem and start investigating what is the root cause of the problem immediately. In other words, we by having real-time observability with alerts, you reduce your time to mitigation because you can start that mitigation sooner because you know there's a problem sooner, and that at least gives you the opportunity to correct the problem before it becomes a much bigger problem. And that's really key for live events or real time streaming or real time e commerce or gaming. Anything that's real time, interacting with end users. So that's the critical value of your observer solution being real time and also being super comprehensive with all of the logs and not just some summarized metrics. You can
Mm.
actually see where the problem, often you can see in the dashboard itself where the problem is occurring. You can say, oh, well, that increased time to first byte actually seems to be happening in this one CDN point of presence and none of the others. And then now you're zeroing in within seconds on the actual root cause, and you can go to your CDN and see what's going on and see if you can mitigate the issue before it becomes a bigger problem.
Yeah, that's awesome. Um, as you talked about, with Hydrox being on the marketplace or being really almost like off the shelf or out of the box
Mhm.
solution in that way, when companies are going to evaluate an observability solution, what are some of the key criteria they should look for or they should consider when they're thinking about the total cost of ownership?
That's a good question. Yeah, it's not just the cost of the license for the service, right? And that's why on our website we actually provide calculators for total cost of ownership, not just what you're paying us, because we're confident that our total cost of ownership is significantly less than most competing solutions. But yeah, it's super important. So not only yeah, so there's a lot of variables here, right? Am I paying you, the vendor, for the storage, or am I storing it in an S3 bucket in my account, right? That's very different
Mhm.
because one means it's included in the cost that you're paying that vendor, and the other one is that it's on your AWS bill. Um, there's potentially data transfer costs. Anyone who's
Mhm.
an AWS customer or Google, I mean, they're not unique in this, but they, when you move, it's free to get data into your services, but it's not free to get it out.
Mhm.
So whenever you transfer data, which would include transferring data to a third-party service like Hydrolix or any of our competitors, um, that could have data transfer charges. So you want to make sure that your vendor is minimizing those data transfer costs by hosting your instance of their solution in the region where you want your data, so that there's no inter-regional data transfer costs between the storage and the ingest and the querying and all that stuff. Um, so yeah, total cost of ownership is really important, and just looking at the observability vendors' product cost is not always indicative of your total cost. In fact, it rarely is. Um, so yeah, we provide a calculator on our website where you put in your volume
Mhm.
uh, and what services you want to log, and we will include our costs, storage costs, all the costs that we know about that are likely to impact your total cost of ownership. Okay.
Sweet. For companies that are interested in trying hydraulics, like what does the implementation process kind of look like? Like how quickly can they start seeing the value?
Yeah, like I mentioned earlier, less than 15 minutes. So we actually recorded a demo of me
Mhm.
actually from, being in AWS Marketplace on our product page, clicking
Mhm.
the purchase button or the free trial button if you're doing a free trial, and recording the entire process in real time in terms of onboarding, meaning we get some basic information about you, we validate your email address, and then we build you your solution on one of our clusters in our account. We create your project. We, set everything up on your side as well. We create the S3 bucket, the connections between the two, and set you up within 5 minutes. You're set up with an active deployment. And then you pick to get an active dashboard, you pick a data source. So you configure your product, your hydraulics service by picking one or more data sources to set up. For example, I want to set up CloudFront real-time logs so I can monitor in my CDN. Click the button. It starts going through a checklist of tasks to let you know what it's doing on the back end. We create your Kinesis stream to get your CloudFront logs to us very quickly. We set up a table for you. We automatically apply the CloudFront transformation to the table so that we can accept the logs and transform them into the format we need. We deploy a pre-built CloudFront dashboard for you, Grafana dashboard, and then in about another seven-ish minutes or so, 7, 8 minutes, you have a link to a dashboard. You click on it, and you have a live dashboard for CloudFront. All you have to do is go to your CloudFront distribution and tell it to start sending logs to the Kinesis that we created for you. So we really do automate everything but that last step, where you just have to start sending us the logs, and you will start seeing live data on your dashboard in less than 15 minutes.
That is awesome. All right. As we begin to wrap up, I wanna pick your brain about kind of like looking ahead or like future state, right? Like looking ahead, how do you see the observability landscape like evolving, especially as more companies adopt edge computing and distributed architectures?
Yeah. Um, well, I'm always hesitant to make predictions of the future. Very few futurists are accurate, but I'll take a few guesses. Um, what I see and I hope continues is that our offering, by disrupting that decision of cost versus retention, um, we have broken that cycle, right? So for the
Mm,
longest time, all of our customers they just knew from experience, because it was the only options out there available on the market, that they had to make that choice, that whatever their budget could support, then that would dictate how long they could store their logs. And then based on how long they could store their logs, they would decide what use cases were and were not viable for those logs. We've broken that. We said, no, we can reduce your cost and drastically increase your retention. And I hope, and we've already seen that start to take hold and become sort of at least in the early stages of becoming an industry norm. And so I think that
mm,
will require a lot of other companies to adjust to that new expectation. And so I hope that that trend continues. The the other kind of futuristic stuff that I think is going to start happening more and more is again around AI, right? So
mhm,
today, transforms and dashboards are not straightforward to create, right? So that's why we pre-package them based on our experience with
mhm,
extensive experience with other customers, and then customers can just tweak them from there, add things, delete things, move things around. But if you want to fully create your own dashboard, you can. We give our customers full edit access to their instance of Grafana. They can create entirely new dashboards to their liking. They can even create their own transforms if they want to transform the data or add new fields or whatever. But those are not common skill sets. You need to know what you're
mm,
doing. You need to be a SQL expert to do a transform, and you need to be a Grafana expert to create a Grafana dashboard, or we support other visualization tools as well. But
mm.
you get my drift. It's not a common um, skill set, I should say.
Right.
So what's exciting is that we're getting really close to the point, and we've been testing this internally, where you could literally just ask a large language model to make a
Mm.
dashboard for you, and it does a pretty good job. It's actually surprising, because you're really just writing JSON, right? Is what
Yeah.
Grafana dashboards are. So, and that's a language, and so it shouldn't be too much of a surprise that a large language model is good at languages.
Yeah.
Um, so that's exciting because it could really open up so that our customers are no longer um, sort of beholden to the dashboards that the collection of dashboards that we've decided to create. As useful as they may be, they may have unique needs that aren't met. And so that's exciting that they could potentially go and just um, have AI create new dashboards for them without very quickly. And the same thing with transforms. Transforms are actually or AI is getting pretty good at writing transforms as well. The other, I think, really cool use case that's exciting and I think will become more and more common is the natural language interface. So
Mm,
imagine, instead of a dashboard, so if you take one of our dashboards, it's really comprehensive and really meant for like network operations, control center people, and you show it to, I don't know, your typical VP of marketing or a CEO, they may be challenged to get the information out of that dashboard that they're interested in. But
mhm,
imagine if you just had a chatbot on your dashboard, and a person like that who's not deeply into the weeds around, HTTP error responses and byte ranges and all that stuff, they could just type in a question and say, how many simultaneous streamers, what was the peak simultaneous streamers in Rio de Janeiro in our last event? And it could formulate a SQL query and do that search for you and come back with an answer. No pre-built dashboard needed, right? So I think
yeah.
that those kinds of things are exciting, I think, natural evolutions in the observability space that we're already um, in various stages of making offerings for in our own products.
That's awesome. Speaking of that, on this last one, I know I said we're wrapping up, but this has definitely been on my mind. Um, how does automatic scaling work? Like, what triggers scaling up or scaling down in events?
Oh, okay. Um, I'm gonna have to put a disclaimer on this one.
Okay.
It's a really deeply technical um, area of our platform, and I
Yeah,
know just the very top surface layer
that's
of
that's
it.
fine.
So, but yes, our architecture is completely deconstructed, right? So
Yeah.
traditional databases, data lakes, data houses, whatever flavor of really large cloud-based database you're looking at, they were monolithic code bases. So because they were originally designed to all run on a single physical server, right?
Mhm.
So you had everything. You had query, you had ingest and transformations and storage and all that stuff, all those functions were in one monolithic code base. And then if you wanted to scale, you had to add more servers, but each
Mhm.
server had to have all of the functions on it, right? And so if you wanted to scale up your query capacity, you also had to scale up all your other capacities, your storage, your intake, your ingest, your transformations, all that stuff, your mergings, all your functions had to scale up together and scale down together. So what Hydrolix did from the very beginning is they built a cloud native architecture. They completely deconstructed all the functions into individual functions that run as their own services, and each of those services can use Kubernetes to automatically scale up and down the number of nodes it has at its disposal to handle the capacity. So for example, if a large event spike happens and a bunch of new logs are coming in, and the rate of ingest is increasing, we can see there's a backup queue, right? We have a queue, a log
Mhm.
event comes in, we start processing it, another one comes in behind it, waits in the queue, another one comes in, and the queue is still long. And when it gets to a certain point, we set off an alarm and say, hey, we need more capacity. We're falling behind here. um,
Mhm.
and so we just spin up new Kubernetes nodes automatically. And as soon as those nodes are up and running, they advertise to the incoming load balancer and it starts load balancing to those new nodes. The load is spread out. Then when the queues fall down below a certain threshold, the signal gets sent out, hey, we don't need this much capacity anymore. To save costs, we should scale down. So we just scale down the number of nodes. And we can do that on an individual service by service basis. So even if you have a spike in ingest, if your query load is really low and you don't need more
Mhm.
query capacity, we can just scale up your ingest compute and not your query compute node. So super that makes us super cost effective just as a platform in general, and super
Mhm.
flexible in terms of auto scaling just the functions that we need auto scaled up and down.
That's awesome. Well, you have answered all my questions. I leave this conversation way smarter. So,
Glad I fooled you.
yeah. So I'm grateful for your time. Ladies and gentlemen, we'll talk to you later.